Welcome to X1T Gaming, and together we're going to revolutionize the game industry. So, I'm going to try to do a couple more streams today. We'll see how we go. I know YouTube doesn't like you doing too many live streams during the throughout the day. I think they just want you to do like one or two. So I'll try to do 3 today. See if YouTube will let me do that. So, what we are process on. So we already have this, as we're on part 2. Now we just got to make the steak and the dogs disappear when they run off the stage. So we got all this stuff. Press spacebar. Boom, 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 boom. Creates all those food clones. Boom, 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 boom. It works pretty good. That's actually pretty exciting. Okay, so now we just got to make sure that they get deleted when they go off stage. Otherwise, you'll just kind of overload the system with so many stuff. But before that, I wanted to see if he has the make animals into prefabs. I'm just going to quickly look at this video, see if he's actually like changing anything.
Before we make opposite direction, we want
opposite direction. We did that yesterday.
Bigger. We'll make it faster. So that way it's a little bit more difficult for the player to throw the food at it.
The dogs have different...
Maybe to like 5.
Animals have different speeds.
And then the dough.
Okay, on his video.
So now our animals are moving forward just like our pizza is, which is awesome. Though they all share the move forward script, because the move forward script itself is unique on each object, they're able to have all these different speeds. So the pizza can be at 40, the moose can be at 15, the fox can be at 5, and the doe can be at 10, because each of these is just unique to that individual animal. And in our prefabs, if we actually go to open prefab on the right, you'll see that these values were saved when we turned them into prefab, which is super helpful. To go back to our scene view, we'll click this little arrow next to the animal doe.
Because I did that bit.
This will bring back to our scene view. And now to really test to make sure that this works, we're actually going to remove all of our animals from our project hierarchy, so they remove from the scene. And now when we press play, as we drag all of the different animals onto the scene, you can see that they start moving on their own. And now we can drag as many as we want.
Oh.
It's like a little army of animals marching off into the distance as our pizza flies away. So now what you're going to do is you're going to go into each of your animal objects and you're going to turn them all 180. And now to really test to make sure that this works, we're actually going to remove all of our animals from our project hierarchy, so they remove from the scene. And now when we press play, as we drag all of the different animals onto the scene, you can see that they start moving on their own. And now we can drag as many as we want. It's like a little army of animals marching off into the distance as our pizza flies away. So now what you're going to do is you're going to go into each of your animal objects and you're going to turn them all 180 degrees.
So we did all that.
And then you're going to...
Now we're going to destroy the projectiles off screen. So it's going to be for the food flight, destroy projectiles off screen.
So we've made some really good progress. We've made all of our objects in our scene able to move. So you have that pizza that flies off into the distance. We have the animals that are marching off into the ends of the world. And then we have our player here, and if I go to the game screen, you can move them back and forth. And one of the problems that we have is we have all of these things that are able to march off into eternity, and we can even generate all of these different pizzas, and this is actually going to cause a huge problem for our game later down the line, as we have all of these different objects in our scene that are constantly flying away, constantly being updated. You can even see all of the pieces of pizza flying away our animals are still marching along, so they never actually disappear from the game itself. So in order to do that, we actually need to create a way to remove them from our game when we don't actually see them in what the player should see. How we're going to do that is by creating another script to be able to manage that interaction. So we're going to go into our scripts folder and right-click, create a C# script, and we're going to call this script destroy out of bounds. Definitely a very long script, but make sure that it's named properly. And now, what we're going to do is we're going to take destroy out of bounds, and we're going to add this script onto our piece of pizza in the scene. And then if we click on the pizza, we just make sure that it's attached. Perfect. Now, if we open the destroy out of bounds script, now we're going to use an if statement to check whenever our piece of food flies out of the bounds of what we can see on our game screen, it'll delete that object from the game. So if we use an if statement, and we'll leave the conditions for now, and then we use those curly braces. So we want to get the current object's position, so we'll do the transform to get that, and then get their position. And since everything is happening on the z-axis, we'll get the z of our piece of food, and if our food flies greater than, let's say, 50 for now, there's a really helpful method that we can use in C# called destroy. Now, destroy actually enables us to remove a game object, we can remove components, we can remove assets, and so we'll use destroy to remove the game objects on the screen that are no longer actually within view of our player. In this case, since we're actually calling the object itself, we can just use lowercase g, game object, and this will be the current game object that this script is applied to. So now when we save, if we go into Unity, and let's position our camera a bit better to see where the pizzas disappear. So when we press play, if we watch the pizza, it flies off into the screen, and then it deletes right about there. So we can probably make it a little bit less. So we'll set this to, let's call it 30. And in fact, we're just going to make a variable for this just in case we need it for later. So we'll call it private, since we know just about the size that we need it to be. This will be a float, and this will be our top boundary, so top bound. And then we'll just say 30. And then we'll change this 30 to our top bound. And save. Back in Unity, we can watch the pizza. And when they fly to the top boundary, we can even expand the game scene. Oh, that's weird. I think we broke something. You can still see the pizzas flying off. That's strange. How come that didn't work? Well, remember when we made prefabs? So we created this prefab on this pizza, and we have the destroy out of bounds script. However, adding the script to this object in the scene doesn't actually update all of the prefabs. In order to do that, there's actually a little button over in the top right of our inspector called Overrides. And if we left-click Overrides, you can see that it actually tells you that something's different between this piece of pizza in the scene and our prefab itself. And so the destroy out of bounds script is actually new. So if we apply this, now all of the pizzas that we create when we instantiate them should have that script applied. So one more time. Pizza flies off, disappears. More pizzas, and they all disappear. So, perfect. Now we don't have a million pizzas flying off into the distance. So, now what you're going to do to be able to destroy all of these pizzas in the scene is you're going to...
Okay, so mark down as complete. And then we're going to do the same thing with the destroy the animals, but you do a lower bound thing at minus, well, they want to see minus 10. Okay, So we'll do destroy out of bounds. We'll have a private float again, so we want to copy and paste this. We're going to call this, was it lower bound, and it's going to be -10 is what they said on the thing. And so then we're going to create another if statement. Oh no, we're going to add
the world. So we're going to fix that really quick. What we're going to do is we're going to apply our destroy out of bounds script to all of our animals. So if we click on the first animal and then shift click to highlight all of them, then we can just click and drag our destroy out of bounds script and drop it on. So now they all have destroy out of bounds applied. However, destroy out of bounds only really works right now for the pizza whenever it goes to the top boundary. We want it so that when the animals get down to the bottom, they get removed. So in our script, we're going to add another variable. This variable we'll call lower bound, so it'll be very similar, private, float, lower bound, and we'll set this to about -10 just so it's under the player. And now we're going to use a new programming concept called else if. So very similar to if statements, but something that you actually add onto the end of an if statement. So if I type else if, and then we do parentheses for whatever condition we want to happen, and we do curly brackets, and we press enter. So the way you would read this is if this thing happens, then it'll do this. Else, if this thing happens, it'll do this thing instead. And so then this way you can cascade different things that you want to happen in case there are unique conditions you're trying to fulfill. So in our else if statement, we're going to find the position of our animal. So our transform.position .z, and if this position is ever less than our lower bound this time, then we're going to destroy the game object instead. Cool. Close that. So now if we save this, and then we go into Unity, now if we look below the player, when we press play, when the animals move down past the player, they actually get destroyed from the scene. Exactly what we want to happen.
Yeah, I guess, I don't know, for me it might be easier just to keep doing if statements, because I don't see anything different between the if and the else if, except for the fact that there's else in it. Oh, but maybe you have to go like new game object and stuff like that if you want to fit. You know what? Let's test it out. What happens if I just do another if statement rather than okay, let's see if I have another if statement, what that would do. Yeah, it still does the same thing. So, yeah, I don't know what the else if means. But let's just keep it like that. Because it might he might have some, it might work something later that we're going to do. Okay, so we'll do mark step as complete. Lesson recap, we'll mark that step as complete as well. And then we'll work on our next project. So, yay, I'm almost programming level 1. 65 more XP to go. Super excited. Okay, random animal stampede. So now we're going to have them load randomly, which will be pretty cool. Okay, create a spawn manager. If we are going to be doing all this complex spawning of objects, we should have dedicated script to manage the process as well as the object to attach it to. Nice. Okay. This is new stuff right here.
Awesome. So our project's in a really good place right now. You can see when we play our game, as our food and as our animals leave the scene and leave the player's view, they get removed. Same thing whenever we create these pizzas on our own. Now, one of the things that we have to fix is we need to be able to make animals spawn in our scene, and we need to be able to make it do randomly, so that way it's a little bit more challenging. So we're actually going to use some code to be able to do that. So what we're going to do is we're going to go into our project hierarchy on the right side. We're going to right click in the hierarchy and we're going to create empty. Now we've created an empty game object and we'll use this game object to actually store our script. We're going to actually call this game object our spawn manager because this is what we'll be using to actually manage all of the spawning of all of these animals on the screen. Now, we're going to need an actual script to be able to spawn all of these animals in random locations in our scene. So in our scripts folder, we're going to right-click on it, and we're going to create a C# script. And we're going to call this script our spawn manager. Now, we're going to attach our spawn manager script to our spawn manager game object. And so if we click on the spawn manager, you can see that we've now attached this script to it. You can see where our spawn manager is in our scene, right in the center. It's invisible because it doesn't actually exist, so you can't see it on the player screen, but we know it's there, and that's how we'll be making all these animals spawn. So if we double-click on Spawn Manager, now our Spawn Manager script opens up in our IDE, and what we're going to do is create a new variable. Now, just to see what this game object does, we'll make it public for now. And we'll make this a game object because it's supposed to store our animal. And now what we're going to do is we're going to use something called an array to store all of the different animals that we have. Now, the way that you would use an array when you're programming is you would actually use our square brackets. So instead of pressing Shift to create those curly brackets that we would use in all of our statements, instead we're just going to press the square brackets, and these two side by side means that we've created an array. Now an array in programming is something that you can use to store multiple objects, multiple variables inside of. So say we had something like a bookshelf and we had 4 different shelves. And so those shelves we would use to store all of our books onto. We'll call this array animal prefabs, so that way this array stores all of our animal prefabs that we've created. Now, the way that you would read this line is that we have a public game object array of animal prefabs, or an array of game objects which we'll call animal prefabs. An easier way to see this is if we actually go back into Unity after we save. Now, in Unity, you can see that we've created this public game object in our script. And if we go to our Spawn Manager, underneath Spawn Manager, you can see this Animal Prefabs dropdown. So if we expand it, now you can see that's asking us for our size. So this is the number of items that we actually want to store in our array. So for example, say we want to store 4 items. It'll ask us what 4 things we want to store. Now, if you're in a newer version of Unity, the size field will actually be over here if you want to enter the number manually, or there's this little plus and minus button that you can click on to add or remove items one at a time in the array, but it's basically the same. All of these different elements are all of the different boxes that we can put our game objects in. If I were to change this to something like 3, in Unity, it would actually change the size of our array as we need it. Because we only have 3 animal prefabs, we only need to make the array a size of 3, so then that way our array can store 3 different game objects. So what we'll do is we'll left click and drag each of our prefabs into one of those element boxes. And now all of the animals are stored in this array that we have in our spawn manager script. So what you're going to do is you're going to create an empty game object.
Okay, so that's pretty interesting. Different parentheses. You got the square, you got the regular one, and then you got the squiggly one. So far, what I understand is the regular one, you just you use it to kind of tell everything. That's the majority of programming. Then the squiggly one so far is just for if statements, or it's like a secondary kind of a thing that attaches to the first statement that you have, and then you have the square, which is for multiple objects. Okay, spawn an animal if S is pressed. Okay. This one.
All right, so we've created our spawn manager and given our spawn manager an array so that we can hold each of our different animal prefabs. But that doesn't really do us any good because we can't actually spawn anything now. So we're going to create something in our code so that we can actually spawn these animals. Going into our IDE, inside of our update method, we're going to use an if statement like we did before to create all of the different pieces of food that we were throwing into our scene. And we're actually going to use a key code to be able to spawn all of those animals. So if we use our input manager, we're going to get the key down for when our player presses a key. And this time we're going to use another key code. And we're just going to use S on our keyboard because we're not going to use that to move right. Now, in Unity, the way that we're going to pull each of the different elements from our array of animal prefabs is actually using these elements over on the side here. So you can see element 0 is the animal doe, element 1 is our fox, and element 2 is our moose. So in our code, each one of those numbers is actually how we can call each of those different animals. So, for example, if I use 0, this should give us our doe. And now we're going to need a place to actually create this animal. So in our case, we're just going to spawn the animal just above the screen that the player can see. So using a vector 3 for our position. We don't need it to be anywhere on the X. We don't need it to be flying in the air on the Y. And since our top bound was set to 30, we'll just spawn the animals at 20 for now. And we need to make sure that the rotation of those animals is properly set up. So we'll use our animal prefabs again. Use those square brackets. And we'll use 0 for now. And then we'll get the rotation of that animal. So if we save and we go into Unity, so our doe is element 0, and when we press play and we press the S key, you can see that a doe spawns every single time. So in our code, to make this a bit easier to control and so that we don't have to keep using this 0 every time, we're going to make a new variable and we'll call it public for now so that we can interact with it in Unity. Now, in this case, we're actually going to make this number an integer because it has to be a whole number. If we actually try and use a float, then our array will get very angry at us. And we'll call this the animal index. Now, in an array, each of these different numbers is actually called the index, And so in this case, because we didn't assign this a value, it'll be. You can see that does spawn in the scene. If we change our animal index to 1, and we press S now, we have these foxes that spawn. And when we change our index to 2, it'll be pulling from element 2, so we should have mooses that spawn. So now we have a whole herd of moose going down the screen. One thing to note is if we make the animal index 3, and now if we press S, you can see all the way at the bottom of the screen that we're actually getting an error. You can tell it's an error because it's got this big red exclamation point and all the text is red. And this is telling us that the index was outside the bounds of our array. Now, because we don't have an element 3, and we're trying to get an element 3, our array doesn't like that. However, if we put this back to 2, and now if we spawn animals, it works perfectly fine. So always make sure that you keep your index inside the size of your array to call the proper element. So now what you're going to do is in your spawn manager script, you're going to create.
Okay. So now we're going to spawn them randomly.
So we've made it so that we can choose one of the different animals to spawn from our spawn manager by using the index to select one of the animals in our array. Now, there's a better way to do this to be able to randomly select an animal that we need so that it can choose an animal without us telling it which animal we want. Now, what we're going to do is we're actually going to use another method in Unity called random. Now, before we get into randomly selecting which animal that we want to choose, we're actually going to rearrange our code to make it a lot more structured and organized. So, in the past, we've always put our variables at the top of our scripts. What we're actually going to do is we're going to take our animal index, and if we cut it with Control or Command X, and we go into our if statement and create a new line, and then we paste that line of code. Now you can see that our animal index is down inside of our method. We can actually remove this public. Now, where you put your variables in your script matters a lot. Typically, if you have a variable that you're going to use throughout your code, you should actually put it outside of any method, so that way I can actually use the animal prefabs down here in update, or I could use animal prefabs here in start if I wanted to. We've moved our animal index down into our update method. So the animal index variable can only be seen within this method. In fact, if we try to type in animal index into our start, our method has no idea of what we're talking about because it doesn't exist. Versus if we type in our animal prefabs, you can see that it auto-completes for our prefabs. So now, in our animal index variable is where we'll be selecting a random number that we can then use to select a different animal prefab from our array. Now, we're going to use something called random, which is a class used to generate random numbers, and we're going to use a method called range. And so this will pull a number between the first number that we select and the last number that we select. So in our case, the number that we want it to start at is 0 for the first element of our array, and then we're going to set it to 3. Now, it's important that it's set to 3 because it will actually count through 0, 1, and 2, but it won't use 3. The 3 is what we call an exclusive number, and so it won't actually use that number, but it will use it as the maximum number that it will go up to. So now if we save this, and if we go into Unity, and we press play, Now whenever I press S, a random animal should spawn between the 3 different animals we have. So now that we know that that works in our spawn manager script, we can actually clean this up a little bit. A really cool feature of arrays is that it can actually track the length of how large it is itself. So if we type animal prefabs for our array, and we type dot, we can get the length of the array. And since the length of our array is a total of 3 elements, it'll actually set it to 3 itself. So if we save once again, in Unity, when we press S, different animals will spawn using our random range.
It's pretty interesting.
So you're going to take our public integer.
Okay, so we're just the reason why, like, there's some stuff that I always get confused because I'm like, 3 is so much easier to just put an animal prefabs dot length, but in order for you to not have to remember that, you could just keep using this every single time. So like, let's say you have like, oh, I don't know, maybe I have like 70 things that I have to do. Well, you just put this length and then it will pick 71 because you might forget that you're supposed to do one extra. So this will always do the one extra. That's pretty interesting. So it's kind of important to do those things. Okay, randomize the spawn location. Okay.
All right, so we've made it so that we can spawn all of these random animals, which is awesome. The problem is that they're all just spawning in the same place, and that's definitely not what we want to happen, so we're going to use random again to move them around our scene. Now, to get our animals to spawn in random places, we're going to go down into our update method, where we actually set the position of where we want them to spawn. Now, for this 0, because we don't just want them to spawn in the same place on their x-axis the entire time, we're going to use a random range here. And for now, we'll just set it to be between like -20 and 20. That way it has a wide area of which it can spawn all of the animals. Now, if I save this and I go into Unity, when I play my game, now whenever I press S, of which it can spawn all of the animals. Now, if I save this and I go into Unity, when I play my game, now whenever I press S, you can see that all of the random animals are now spawning in random positions, which is awesome. That's exactly what we want. Now, our instantiate method is getting a little bit messy down here. You can see that we have our animal prefabs array, but then we have this huge line of code right here. So we're actually going to create another variable inside of this method for this. So underneath our animal index, we'll create a vector3 variable since we're trying to store a coordinate. And we're going to call this the spawn position, or spawn pause. And in here, we're actually going to just take this entire line for our vector3 that we generated randomly. We're going to cut that with Control or Command X. We'll paste that into our spawn position. And then we'll replace what was there with our new spawn position. And so now we're just using a variable to be able to store this line of code right here. One small thing that we can do better is we're reusing these numbers a lot here. And so we know that in our random range, this -20 and this 20 is the range of our x that our animals can spawn at. So we'll create a variable private float so that we can get very precise numbers that animals can spawn at. We'll call this our spawn range for the x, and we'll just set this to 20. And then we can remove this -20 and 20 to be spawn range x. And then since we know that in our spawn position that we're always going to be spawning things at 20 on our z, we can just make another variable for that. And then we'll remove this 20. And so now we can use variables to make our code a lot more readable and make our lives a little bit easier, especially if we ever want to change our x values or if we want to change our z value to maybe spawn a little bit higher. Now we can easily do that and we don't have to change all of these numbers all at the same time. So now it's your turn. You're going to create 2 new private float variables for the range of
Let's see if it works.
the x and the position of the z that animals will spawn at. And we'll set both of those to 20 for now. And then down in our if statement,
Try to see what I did wrong. So spawn range x minus spawn range x. Okay. Okay, so we fixed it. Boom, 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 boom. Doggy attack. Okay, so this is what I'm seeing. So now I understand why you want these long words here, because I know you're like, oh, you're trying to simplify the code, try to make it longer, but it makes sense because now all of this stuff is here. I could just change the numbers fairly easy up here if I want to change something. So I'm like, oh, the range X I want to change here. I can always make this public so that I could change in the actual Unity program. Then this way I don't have to read through all the code to try to figure out where it is and redo it. That's pretty interesting. That is pretty interesting. So this is going to be like the complicated code part. And then this is kind of like to get the numbers so that you can adjust it easier without having to read everything. And then you have the name, so you know what it is. You're like, oh, spawn range X on the X axis and then the spawn position on the Z axis of what position, and this is going to be like a range. Okay. And then these you could pretty much name whatever you want. Yeah, you just want to name it something that you can know. And as long as they're spelled the same, doesn't care. Because you're creating. Okay. Nice. I think we're getting this. I think we are getting this. So mark step is complete. Okay, change the perspective of the camera.
Alright, so our game is coming along really nicely. You can see all the animals as they spawn. You can spawn them in random places. We have different animals spawning. We can throw our food. And no matter how many things we create, they all get removed from the screen when they leave the player's view, which is perfect. Now, we can actually mess around with the camera a little bit. So some cool things that you can do, especially since this is a top-down game, so it's kind of 2D-ish. Now, say you want to kind of see what this perspective was like in our game, in our scene view. So you might notice underneath the little tool that helps us change the different sides that we can view from our perspective, we have this tool over here that enables us to shift between what's called perspective view, which is what we're at right now, to isometric view. So you can see that everything turns a little bit flat. So if we do that again, so you can see right now we're in isometric view. And if you watch any of the animals, you can see that they actually develop a lot more definition and depth on the side versus if we do isometric, where everything turns flat. Now, to do a similar thing within our game view, we can actually manage that through our main camera. So if we click on our main camera in the hierarchy, you can see underneath the camera settings, there's a projection variable. And if we left click on the drop-down, you can see perspective, or we can go to orthographic. Now, if we click orthographic, you can see that all of the animals become flat again. But you can see that they still have shadows because there's still depth and light involved. And so shifting between perspective and orthographic is a really cool way to get different kinds of detail in your game if you're looking for a certain kind of feel. So just make sure you save whichever way that you want your camera to be, and then take it from there. So what you're going to do is in your scene.
Sweet. Okay, so that's the lesson recap. We're all done for that one. Interesting. Okay, so I think we're going to call that quits for now. And then we got collision decisions. This is going to be the next one. Yeah, so instead of pressing S to spawn the animals, we will spawn them on a timer so that they appear every few seconds. We're going to work on that next, so I'm going to go break for lunch. I'm going to break for lunch, and I don't know about YouTube, their policies about how often I could go live. So if you don't see me back later today, I might just do a recording and then post it on YouTube later. So then at least I could get everything as a flow done. And yeah, I'll do it as a recording. So I'll just keep doing lives until I could do lives. And then if YouTube doesn't allow me to do lives for the rest of the day because it's been too many, because there was this thing that they don't want you to do too many lives, then I'll just do a video for you guys. So then I can keep on time. And then tomorrow I'll be working, so I won't see you guys until 9 tomorrow. Yeah, so I'll go break for lunch, and then we'll come back, do another hour and see where we go from there. Because I gotta go do some classes. So we might just do three recordings today. But that's okay. Just taking time, and we're learning lots. Gotta absorb all this stuff in. It's actually very interesting. Um, yeah, no, I'm enjoying it. I'm getting it. I'm figuring it out. It's pretty good. So then I think we're almost done this prototype 2, and then we'll do another session for the 3. And I think there's going to be 5 prototypes in total, because we already did 1, which was the car. Now this is the animal. Then we got, what are the other ones? We got one for sound, so we're gonna have a guy jumping up and down, and then we're gonna have one for animations, and then we're going to have one for, what was it? Oh, I think the bouncing or whatever, 3D kind of stuff, the rolling balls. So yeah, I think there's 5 prototypes in total that we're going to have to get through. I'm going to have to get through them as quickly as possible so that I could actually start working on my game. I'll probably have to go look back at some of these prototypes just to kind of get my bearings on how all the scripts work. But yeah, no, I think I'm getting it. This is pretty good. It's just like a language, and you're just trying to tell the computer what you want it to do, and learning how to do that. And then once you learn how to tell the computer what you want to do, I guess sky's the limit for whatever you want to do. So that's exciting. I'll see you guys later. I'll go break for lunch. You guys go have something to eat too, and then we'll come back, and hopefully we could live stream again. But if not, I'll do a recording for you guys. Okay, see you guys later.